This is 2018 past paper questions. Let's move to 2018 past paper questions, which is mainly from the traveling microscope. If I'm not mistaken, this is the very first questions which they ask based on the traveling microscope. You can't find structured type questions from traveling microscope. Actually, these questions link with the optics part, but the first few questions you can do based on the theory or based on the concept that we learn under traveling microscope. Let's start the question. So you are asked to find the refractive index of glass used in rectangular block of glass and a traveling microscope. You are asked to find the refractive index of glass used in rectangular block of glass and a traveling microscope. A small amount of lycopodium powder, a piece of white paper cut into the size. There's a small typing error. Can you please make it there? Cut into the side. Cut into the size. Cut into the size. Cut into the size of glass block. So you have a glass block like this. Glass block. There's a small white paper which is exactly in the same size as this side. Glass block, and also provided letter X is marked in the middle of the white paper. Diagram of a traveling microscope that can be used in this experiment is shown in figure. Right. In the first question they asked, identify the parts marked with A, B, C, and D and briefly state their function. Briefly state their function. What is part A? Part A is a fine adjustment knob. Fine adjustment knob. Slow motion knob. You can write whatever the identification thing here, but it should be a knob which can be give fine adjustment. So if you haven't write it properly, you just write fine adjustment knob. Fine adjustment knob. What is the function of that? So it helps us to fine adjustment the system in a vertical direction, or moving the vertical vernier scale in a vertical direction. You just write under the function to perform the fine adjustment. To perform the fine adjustment in a vertical direction. To perform fine adjustment in a vertical direction. So you may have different answers, but this idea must be there. You may have different answers, don't worry, but the idea must be there to perform the fine adjustment in a vertical direction. What is B? Adjustment knob. Adjustment knob of the microscope. Adjustment knob of the microscope. B. Adjustment knob of the microscope. Adjustment knob of the microscope. What is the function of that? To get the clear image of the object. 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 C. What is C here? It's called the leveling screws. We call it leveling screws. Leveling screws. So what is the function of that to level the traveling microscope setup? So we use that leveling screws to level the traveling microscope bed, or you can write like to level the traveling microscope setup. To level the traveling microscope setup or traveling microscope bed. What is this? Actually, it was not in my instrument. I told you it is the spirit level. Spirit level. Spirit level. We call it spirit level. What is the function of that? To verify the leveling. To verify the leveling, whether the leveling is now okay or not. You can verify it. To verify the leveling. If your all answers are correct, you get 2 marks. Just for you to get kind of information how the marks are allocated. If only three answers are correct, even you get 2 marks. If all 4 are correct, 2 marks. If all 3 are correct, 2 marks. If 2 answers are correct, let's say A and D is only correct, others 2 are correct, others 2 answers are wrong, you get even 1 mark. If 1 is correct, you don't get any mark. That's how the marks allocation takes place. Or if you get 3 or more than 3, you get 2 marks. 2, 1 mark, less than 2, you don't get marks. Right. This is 2018 past paper question. Before starting the experiment, while familiarizing with the traveling microscope, a student observed that when the fine adjustment knob relevant to the horizontal movement was turned, the corresponding vernier scale did not move. Give the reason for this. What is the reason? What was the reason? So you remember there is a F lock. It is called the locking knob. You can take that as a locking knob. Or you can write simply F. If knob is not locked, that is the reason. How much you rotate it, it is not move. The reason is it is not locked properly. If knob is not locked, if knob is not locked, so you get 1 mark. If your answers are correct, you get 1 mark. If you have anything, please ask. Right. Let's move to part C. An enlarged figure of main scale and the vernier scale of a traveling microscope are shown. Calculate the least count of this traveling microscope in centimeters. If you look at that, you would realize these 50 divisions are equivalent to the distance from this point to that point. What is that distance? It is something like 24.5 centimeter. Sorry, millimeter. It is 24.5 millimeter. You can divide by 50 to find the length of a vernier scale. How to find the least count? 0.5 millimeter is the length of a vernier scale division. Sorry, length of a main scale division. 0.5 millimeter minus length of a vernier scale division. When you simplify that, you would get something like 0.01 millimeter. But what they want, the answer in centimeters, so it is 0.001 centimeter. If your answer is correct, you get 1 mark. 0.001. Since they ask you to keep the answer in centimeters, you are not allowed to keep the answer in millimeters. Remember, read the questions carefully. You should keep the answer in centimeters. If you place your answer in millimeters, you are not getting the marks. Right? Okay. So when we are doing the paper class, I will explain those sections much in detail. So since this is the beginning of the subject, no need to think about those section in much part, but anyway, it's better to learn. Let's move to part D. What is the adjustment that you perform on the eyepiece before starting the experiment? What is the adjustment you should do in the eyepiece? So you should focus the crosswire of the microscope. So I told you you should look through the eyepiece until you get a clear image of the crosswire. So you want to write there, focus in the crosswire of the microscope. So you should focus the crosswire on the microscope. That is the adjustment you should do for the eyepiece. You get again 1 mark for that. 1 mark for that. Now you are asked to place the given piece of paper on stage G. Stage G, what is that? It is the bed, traveling microscope bed. Okay. Now you are asked to place the given piece of paper on a stage G of the traveling microscope and obtain the first measurement with the microscope using the mark X before placing the glass block. Write down the main steps in the experimental procedure you would follow to achieve this. So I did the similar type of questions, similar type of experiment to find the thickness of the glass cube. What I did at the beginning, I place lycopodium powder. Let's say this is the bed, this is traveling microscope bed. I place lycopodium powder and focus the traveling microscope at that point, right? You want to focus it. This is the lycopodium powder. Instead of lycopodium powder, they have given the lycopodium powder. Instead of that, they have given you paper which indicate the cross as X. You have simply a paper which indicate the letter X. So you focus that onto the paper, onto the letter X. That's all. It's something similar to the things I did for the lycopodium powder. Just write under that, write the steps. Unlock the microscope. You should unlock the microscope. No, normally it is locked. Normally it is locked. Unlock the microscope. How to unlock it? We have a locking screw here. You can unlock it. Unlock the microscope and adjust the microscope. Adjust the microscope until an image of X is seen. Until image of X is seen. X is seen. Actually, I did for the lycopodium powder. Until an image of lycopodium powder is seen in there. But in here, you have to take that as X. X is seen. Now it is normally visible. But we want to fine tune it. How to fine tune it? You can use this screw or this knob or that knob to fine tune it, right? Lock it. The next step, lock it. Lock it. Lock it means you have to lock this lock section, lock the H button or H screw here. Lock it. Use the knob A or B, A/B. Both we have to use sometimes A/B for focus in the image. For focus in the image. A/B for focus in the image. Focus in the image. Right. Okay. Up to now you are okay. I guess you all are okay up to now. Let's say you get again, for this one you get 2 marks. For this section you get 2 marks. Right. Relevant position. There's a question. So is that all for the steps? Yes, that is enough. what they want, how to take the, how to get the, what they have mentioned. Now you ask to place the given piece of paper on the stage G of the traveling microscope and obtain the first measurement with microscope using the mark X before placing the glass block. Write down the main steps in the experimental procedure you would follow to achieve this. This is the experimental procedure. No need to write more than that. Even the space is not given for to write a big answer. The one is asking me to repeat the answer for the party. I will write exact answer. That doesn't mean your answers are wrong, right? Okay. You may have the different idea, different answer, but in the same idea. It's okay, no issue. But I better to write my answer because I make it more precise and more focus onto the total idea. But don't think that your answers are wrong. Keep your answer also, but look at my answer. I will repeat again. Unlock the microscope and adjust the microscope. Unlock. If you haven't write unlock, you might get again the marks. Don't worry. But I am highlighting the exact answer. Okay. Unlock the microscope and adjust the microscope until an image of X is seen. If you just write there, adjust the microscope until an image of X is seen, that is fine, no issue. Can you understand my point? I guess you all are okay with my point, okay? Image of X is seen, okay? Unlock the microscope, and adjust the microscope, adjust the microscope until an image of X is seen. Lock it. Initially you unlock it, now you want to lock it. Lock it. Use the knob capital A / capital B for focusing the image. Focusing the image. Focusing the image. Right, part F. Let's move to part F. Relevant position of the main scale and the vernier scale corresponding to the measurement mentioned in E above are shown below. Write down the reading corresponding to the measurement in centimeters. So you have to write the measurement. What is the maximum? What is the maximum measurement that you can read from the main scale only? Here, 4 centimeter. If I go with centimeters, 4.1, 4.2, 4.3, 4.5, 4.6. No, 4.2, 4.3, 5, 6, 7. 4.1, 2, 3, 4, 5, 6. Ne? Okay. 4.65 you can read. If you zoom it more, 1, 2, 3, 4, 5, 6, 6.5. Okay. 4.65 centimeters I can read without any problem from the main scale. The balance I should read from the enlarged one. What you can use to enlarge this vernier scale, what we can use? I told you. The question is not asked there, but I told you what we can use to enlarge that one. Lens, yes, you can use the lens. No, it is not the eyepiece. Okay, we have a separate lens. I told you it is a lens. I told you it's a lens. I told you last time it is a lens. Okay. Right. We can read the vernier scale value from there. Here, this location, 42, number 42. 41, 42. Number 42 coincide with that, multiplied by the least count 0.01. So what is the total answer in terms of centimeters? 4.65 plus 0.042. So altogether how much? 4.692 centimeters. You get 1 mark for this. 4.692 centimeters. After taking the first measurement mentioned in part E above, write down the important steps in the experimental procedure pertaining to the other two measurements that you need. So I skip those two questions. The reason is it is linked with the optics part. So I skip those two questions. Pointless to discuss about those two questions. Here altogether you get 1 plus 3, 4, 5. 5 marks. 5, 6, 7, 8. 8 marks you can take out of 10 for this question. This is 2018 question. You might have different marks, don't worry. These questions are given for the student who complete their syllabus. You are just a beginners, so don't worry. But anyway, we have to manage with the past paper questions. That's why I discussed this question with you. Let's move to question number 2. Also, I discussed the triple B imbalance. Better to discuss question number 2 also. Please look at your answers for the question number 2. After discussing this question, I will move to the small theory part, which is linked with the errors. I will discuss that after discussing this. The following figure shows the triple beam balance when the balance is preparing to obtain mass, MP, MQ, and MR are kept in left corner. When the system is in balanced condition, the moment due to weight of the platform and the object on the platform about an axis through O is equal to the moment due to the weight of the riders and the three beams. So don't think about that. These sections you will be discussed under the moment, equilibrium of forces and center of gravity section. So no need to worry about the moment due to weights and that sort of things. But the simple story I can explain. Let's say you have a something like a knife edge here. You have a ruler or the stick. We have something to hang. Both are equal masses, so you can keep this one in a balanced condition. If this is more than that mass, let's say these are equal distance L and L. If this is more than that mass, definitely it will topple. So these sections, I guess you have done few things under the O level also, but I don't want to emphasize those sections. I didn't do in my class. The reason is these sections are under moment or equilibrium of forces and center of gravity section. That is mechanics number 6. No need to worry about that now. Okay, we can write without knowing those things for when we write the answers. Find the least count of the instrument using the enlarged figure. If you look at clearly, it is a triple beam balance. Here 9 gram, 10 gram. So in between 9 to 10 gram, you have 10 divisions. So 10 division means 1 gram is divided into 10. You can read up to 0.1 gram. 0.1 gram. It is the least count of the instrument. 0.1 gram is the least count of the instrument. If you have anything, please ask. It is a 0.1 gram. The system should be balanced. The system should be balanced when MP, MQ, MR are at x z x sorry x z dash without an object on the platform. If the system is not balanced in this situation, what you can do to achieve the balance condition? Let's say you don't have any mass here. You don't have any mass. Those three riders are at the z dash z location. So now this pointer must be exactly at 0 location. If it is not so, what you should do? You should screw or fine tuning the adjustment screw. We call it adjustment screw. I told you that we call it adjustment screw. So you want to fine tuning the adjustment screw until it is come to the 0 location. This beam is come to the 0 location. I told you that part, right? Just write, if you haven't write it there, by fine tuning the adjustment screw within bracket W, by fine tuning the adjustment screw within bracket W. This is not a past paper question, but anyway, it's an important questions which you can get a certain knowledge again under the triple beam balance. Right. It is required to place MP, MQ, MR properly on the beam so the unknown mass of the object placed on the platform can be obtained. Which mass riders are just in the following way: continuous and discrete. If you remember, we have a notch. We have notch like this. The notch you can observe for MR, you have to take up to this level to take into the notch, then 100 gram is there. When you take this mass at that point, it is 200 gram. Like that, MR, even MQ, it is notch. It's a notch. MR and MQ having a notch. It is a discrete values. In between 100 gram and 200 gram, you can't keep that locations. You can't keep that. Exactly, you want to take either at that point or that point. So in between values, you can't take here MR and MQ, but MP, you have a continuous values, continuous up to 0.1 gram. So what is your answer? Here it is continuous MP, discrete or in a small increment MQ, comma MR. Anything to ask, any one of you? I think all are clear with that. What is the maximum mass that can measure? There's a question. Can you explain it again? Okay. One is asking me to explain it again. I told you this very clearly. You have three beams. You have three beams. In here, we are taking what? MR. The mass or the right MR is taken here. So you should take either this location or that location. I mean the notch. We call it notch. This location is called notch. This location is called notch. I should take MR. MR is the mass on that beam. I should take MR either here or there, or there or here. I should take here. I can't take here because it's a notch. I should exactly come to that location. It's called discrete values. You can't take a continuous values up to 0 to 100 or 100 to 200. Did you get the point? The same thing I can tell you here, 10 gram, 20 gram, 30 gram, like that up to 100 gram. So you can read up to 500 here, 500 gram. Here you can read up to 100 gram. Here you can read up to 10 gram. But remember, the 10 gram is continuous. Continuous. There is no notch. So it's a continuous thing. But in here, it is discrete notch. 10 gram, 20. You can't take 10.5 at that point. It's wrong. You can't take, if it is 100 and 200, you can't take 150 here. You can't keep this mass at that point. That's what I want to tell you. Did I answer your question? Right, okay, fine. What is the maximum mass that can be measured from the instrument when there is no any hanging mass at x and y? Your x and y is here. You don't have any mass hanging on x and y. In this beam, you can measure 500 gram maximum. In this beam, you can measure 100 gram. In this beam, you can measure 10 gram. So we'll write that in like this. 500, you better write like this. In a later stage also, you can understand that 10 gram the second beam plus 10 gram in the third beam. So altogether how much? 610 gram. You can measure 610 gram without any mass. If you want to measure the mass which is more than the part in D, that means if you want to measure more than 610 gram, you can use 1000 gram or 500 gram or both after hanging at x and y, x or y. You can hang at that point or there if you want to measure more mass. If you are given only 500 gram, what is the smallest and the maximum mass that can be measured from the instrument? Smallest. If you already, if you are given already 500 gram, you want to hang it at that location. Now it is 500 gram. Let's say these riders are at that location. So the minimum would be 500. 500. If you take these riders at that point, this rider at that point, this rider at that point, what is the total mass that you can measure? It is 610. So altogether 500 plus 610 means how much? Maximum, minimum is 500 gram. Maximum is 500 plus 610, altogether 1110 gram. It is the answer. Anything to ask? You have anything to ask, Lamai? I think you all are clear with that. What are the important considerations you should consider when placing the mass on the platform? So there is something called center of gravity. Center of gravity. Center of gravity of an object. So this section you will be discussed under mechanics number 6, center of gravity section. But anyway, I just highlight few sections. If I take that as a sphere, the center of gravity is it's on center. If you take a beam like that, center of gravity is at that exact point. There are some situations center of gravity is act. So what I want to tell you, the center of gravity of the entire object must be exactly along the center of the platform. This thing you will be understand in a later stage. So don't worry. But anyway, just write the answer. Just write the answer. Center of gravity of the object. Center of gravity of the object must be kept on the center of the platform. On the center of the platform. Center of the platform. These are kind of, actually this is not the past paper question, but this is some kind of structured question prepared for the student who complete their entire syllabus. So in that case, you are not so familiar with some questions, don't worry. What are the steps we need to take dampen the oscillation about O when balance is reached? When the balance is reached, there is some kind of oscillation at that point when the balance is reached. Actually, Lamai, we have a magnet here. I don't want to discuss about that. There is something called electromagnetism in your syllabus. It is number 7. I will discuss that in under number 7. So don't worry, just skip the question. If I try to explain, it is pointless. It's difficult for me to explain since there are some forces involved with magnetic forces. It's difficult for me to explain for the beginners like that, like you. So just skip that question also. Right. Okay, that's enough.